Hello guys, in this video we are going to see a very basic algorithm of the image registration in Matlab. So this is the code for that. So before explanation of this code, let me first run the code to show you what inputs is it taking and how it is giving the output. So let us first see that and then we will see the explanation of the code. So here you can see that it opens a file browser, and over here you can navigate to the folder where you have the image stored, and the first thing that it needs is a image that has to be transformed. So we are going to transform this image. It again opens a file browser, and this time it wants the reference image. So previously we selected this image, so this is the image that is going to be transformed, and this is the image uh, that is the reference image. So this is going to be transformed like this, such that it is aligned or registered to this image. So this is our reference image. So first it asks for a transformed the image to be transformed. So this is the image that has to be transformed, and this is the reference image. So we have to align this image to this image. So in order to do that, you will have to select some points manually, some corresponding points. So that is, if suppose I select a point over here, so this point corresponds to this point over here in this image. So like this you have to give the correspondences. So which point over here corresponds to which point over there. So like this for now I have told to select 10 points. So this is a variable, you can change this as you want. So the minimum number of points that should be selected is 4, but it is better if you select more points. Try to be as accurate as possible. So here you can see the output. So you can see that this particular image is transformed such that it overlaps or aligns with this image, the reference image. So one thing that you can notice is this particular axis. So this axis, if you see, this is got aligned to this image's axis. So you can see this was the original image, and you can also make out the difference by this line. So you can see this line is a very nice perpendicular line, but over here it has changed the angle. So you can understand how much this particular image has been transformed by looking at this line. So this is what the code gives you. It registers the image that you want to transform to the reference image. So this is what is image registration. So now after looking at this code, now let us see how does this code work. So here I'm using UI get file. So the file browser that you saw to choose the file, that comes because of this UI get file. So this variable a, this consists of the image that is to be transformed. So this particular image uh, goes in a, and this image goes in a1. So I hope you have seen the previous video where I have told how to transform a particular image. So in the previous video I have shown how can you transform any image to some particular transformation given a transformation matrix. So in that video I have explained about this in detail, about what are these things used for, and all that. So we'll not discuss that much over here. So for now I have the image to be transformed in A, and the reference image in A1. So this is what I have now. Next I take the size of the image that is to be transformed in B. So I have the size of A in B. So A is my image to be transformed. So next, this particular section that you see over here, this is to get this kind of a figure window. So you saw that when this figure window came up, I did not click a maximize button or something like that. So this line over here, figure position, get 0 screen size. So this parameters, what they do is they open a figure with a full screen size. So you don't have to press maximize or something like that. Next, you can see annotation over here. So you can see this select 10 points in both the image. So this annotation is because of this line over here. So this is not any title. So this is not the title of the image, but this is an annotation. So this text box that you see over here is just because of this annotation. So you have to tell that it is a text box, what are the parameters. So this is the x coordinate of the text box, this is the y coordinate, and this is the width and the height of the text box. So you can always go into help and type annotation, you'll understand these parameters over here, and then you have to pass a string, what is the text that you want. So this is the text that I want. So yeah, next time using subplot. So subplot gives me this plot over here, this subplot over here. Let me make this side by side, right? So subplot gives me these two plots over here, and then you can see that I have done image. So this is image uint 8a. So here I have displayed the image that is to be transformed. This is that A image, and you see that I have used image instead of im show or something else. So this is very important because what image does is it creates an image out of this matrix. So what so so the advantage of image is that you can use it for G input. So you saw that I was clicking points on the image. So I clicked a point over here and I got its x coordinate and y coordinate. So this particular thing that if I click a point on the image, I need to get its at x and y coordinate. This is done only by image. If you use im show over here, it will not give the x and y coordinate of the image, it gives something else. So because of that, it is very important to use image over here. So you can see at both the places I've used image. So this is very important. Also I have converted to double because I'm going to transform this particular image further. So I have to convert it to double. Next over here, if you see this particular section, so this is a very important section. This section helps you to click the points that are there over here. So let me run this section in a debug mode so that I can make you understand better. So here I run this section to make a figure window. So this section makes our figure window. So let me run this section. So you can see it gives a figure window like this, and let me put this in this side. Now let me run this section and let us run this step by step. So let me come over here, right? So let me run the section. So now this is a loop for I is equal to 1 to n, and what is n, right? So n is how many number of points do you want. So here you can see select 10 points in both the images. So over here n is equal to 10, that means I have to select 10 points in this image and 10 points in this image. So that is what I have to do. Now so the command for selecting a point that is G input. This command selects a point for you. So when I press step, so it will give me this kind of an axis, not axis, sorry, a pointer kind of a thing. So now using this pointer you can select a point. Say I want to select this point, so you can click there, and now this point is selected. So once the point is selected, you get the x and y coordinate of that particular point in x0 and y0. So if you see x0 and y0 over here, it will have the x and the y coordinate. Where is y0? And the y coordinate of that particular point that you have selected. Next I say hold on, and I say scatter. So this scatter puts that point in the picture so that I can understand which is that point over there. So that is scatter. So once I have selected a point in this image, now I have to put that in a matrix. So this we'll see why we are doing this. So this is to make a list of all the points that I am selecting in this image. So the x coordinates of all the points that are going to be selected in this image will go in this x of I, and the y coordinates of the points that I select in this image are going into y of I. So that will we will use that further. So if you have seen my this video where I have talked about image registration, so here you would know that we need this coordinates, this x1 y1 x2 y2 x3 y3, and its corresponding coordinates in this image, the reference image, say x1 y1 x1 2 y1 2 x1 3 y1 3, so that we can further make this kind of a matrix which will help us to create this transformation matrix, this kind of a transformation matrix which helps me to transform this image to align this image. So because of that I am storing these coordinate locations. So I will store x0 in x1 x of I. So if you see x over here, so initially x is zeros. I have initialized initially everything, all x are zeros, all elements in the x are 0. So now step by step it will get filled. So now you have the x coordinate of this selected point over here, and similarly you will have the y coordinate filled at this place in y. So x has all the x coordinates of the points that you select over here, and y has all the y coordinates of all the points that you select over here. Now next we are on this particular point where I am again taking a G input, and this G input is for the other image. So now I need a point which is corresponding to this point. So I'll have to select this. So once I select this, I have the x coordinate and the y coordinate of this point in x1 0 and y1 0. So the same process for this image also. I have scattered, I have done scatter this particular thing so that I can show which point did I select, and the x coordinates of the points in this image will be stored in a x1 variable, because you can see this over here. So all the x coordinates of this image will be in a vector that is x1, and all the x coordinates of this image will be in a vector that is x. Similarly for y coordinates will be in a vector that is y1, and y coordinates over here will be in a vector that is y. So the same thing I have done over here. So now like this I have filled the first points x and y location. So this is the x location of this point, the y location of this point, then the y location of this point, and the x location of this point is over here. So that is what I've got. So now like this it will iterate 10 times, because n is 10 over here, and it will help me to select 10 variables, 10 different points over here, and we will have the different locations of those in x, x1, y and y1. So once we have these points with us, we can create this matrix equation over here. So if you want to understand how this equation has come, so you can click on the link over here where I have explained how has this equation been formed. And once you have this equation, you know that this is known because you have all these coordinates. This is also known because you have all these coordinates, and this is the only thing that is unknown, and that is our main task. We want to find out what is that transformation matrix by which I can transform this image so that it is aligned to this image. So this is our task. Also, it is very important to transfer the origin. So we know that the origin of this particular image is over here 0 comma 0. So this is the origin of this image because it is the matrix. This image is a matrix. So this particular top left corner is our 0 comma 0. So it is very important to shift this origin to the center of the image before applying any transformation. So to have all the points that are selected in this image with reference to this origin, that is the center pixel being the origin, you have to do this thing over here. So x minus b2 by 2 and y minus b1 by b, this basically shift the origin from here to here. So now all the x and y coordinates that you will have will be with respect to the origin that is in the center. So this is very important in order to transform this image. So before transforming, this is a very important step that you need to do. So because of that, you see these two lines over here. Right, so now the other things that you are going to see, let me do quick debugging now. Right, so this section, if you see this particular section, so this section is just to make this matrix form over here. So the first for loop, this particular for loop, this creates this b variable, this b vector over here. So I have denoted it by capital B. So this particular vector that you see over here is capital B in my program. So this is a very easy for loop by which I am just putting this x1 over here, this y1 over here, and the story. That's next. For creating this matrix over here, what I'm going to do is I'm going to have different variables. So this is going to be a1, this column is going to be a1, this column is going to be a2, this is going to be a3, and the story. So what do I want in a1? So in a1 I want x1, so that is the x locations of this image. So you can see I have placed x1 of I. So if it is a1 of 1, that is this element over here, so that is going to be x of 1, that is this. Next, if you see a2, so a2 has to be y coordinate, so hence there is this y coordinate. If you see a3, so a3 is 1, so because of that this is 1. So like this I have filled all the rows over here, all the columns over here, and there is a for loop so that you can create all these elements over here. So once all of them have been created, you can just simply concatenate all of them like this so that you get this whole A matrix. So in my code, the variable for that A matrix is capital A small a, because I'm going to use this capital A further in the code. So the name of this matrix is AA. And once you have got these both things, you just use the least square solution to get this vector h11, h2, h12. So this is the unknown vector that you want. So very simple formula, A transpose A inverse A transpose B. So you can see A transpose into A, and this sign is for inverse. So this total thing is going to be inversed, and then there is A transpose, and there is a B transpose here. That is because the B that is created by this for loop is actually a row vector. So if you see the capital B over here, it is 1 cross 20, that is, it is a row vector, 1 row and 20 elements. But the B that we want should be a column vector. It should have 20 rows and 1 column. So because of that, I had to do this B transpose, that's it. So this is the least square solution that we have got. And we have this, all these, so we have this vector as H. Once we have this vector as H, we just need to put them into this matrix form. So you know that the first element of H is comes over here, the second element comes over here, the third comes over here, the fourth comes below. So that particular thing is done at this line. You can make this matrix like this. So once you have this transformation matrix, your 70% of job is done, because now you know what is that transformation by which you can transform this image. So once you have the transformation matrix, we use the same code that we used in my previous video to transform a particular image given the image and the transformation matrix. So this is the same code. If you have not seen this video, I please request you to click the link over here. You will be directed to that video. And like this, finally we can transform the image, the required image, and our job is done. So we can do this image registration very nicely. Yeah. So that's all for this video. Thank you so much for watching. Thank you.